moving on to question 2 now. We have a question here that's dealing with a cumulative distribution function. So to start off with, we're given this PDF here, this probability density function, and then part A just asks us to show that the CDF can be given by this function here. So for PDFs and CDFs, remember that the CDF is the integral of the PDF. So this is your PDF here, PDF. So if we integrate this, we get the CDF, okay? So we get the CDF. So the nice thing about this one as well, for this question, is that we only have this one part here, this t over 120, then it's 0 otherwise. So the nice thing is all we've got to do is integrate that t over 120, and we're going to get our CDF. So if we integrate this now, it's going to be the integral of t over 120 dt. And the limits, well, remember we're going to start at 4. Now we don't go from 4 to 16, like it says, suggests t is here, t is that interval. We're going to go from 4 to t, okay? And what if we do that, we're going to get our extra part of the integral here, what would be technically like your plus c almost. So if we do that, well, integrating this nice and easy, add 1 to the power, divide by the new power, so you're going to get t squared over 240, and then we just got to use our limits. So put that in a little box. So my upper limit is t, my lower limit is 4. All I've got to do now is sub these limits in. So well, if I put t in here, I'm just going to get t squared over 240, and then we minus, well, what do I get if I put 4 in here? I'm going to get 16, 4 squared, 16 over 240, and if you do that on your calculator, what you get is minus 1 over 15. Okay, so you get t squared over 240 minus 1 over 15, and we also know that f of 4 is equal to 0, and f of 16 would be equal to 1. So there we have it. So that's just how we show that the cumulative distributive, the cumulative distribution function is given using the PDF here. Okay, so this is the key bit here. This is your t squared over 240 minus 115. That's our c here. Okay, so that's part A done. For part B, it just asks us to find the exact probability that the amount of time Lloyd waits to be served is between 5 and 10 minutes. Okay, so remember, to get your probabilities and your exact probability, we use the CDF. Okay, so this is f of 10, but because we're going between a range here, it's between 5 and 10 minutes, we do the bigger one, f of 10 minus f of 5, and that just gives us our probability. So all you've got to do is plug in 10 into our cumulative distribution function here, and then plug 5 in, subtract them, and you've got your answer. So if we do that, that's going to give me, so I'll do it separately in a bracket, 100 over 240. Remember t squared, so that's t being 10, 10 squared gives me 100, so 100 over 240 minus 1 over 15. And then we minus, again, just plug 5 in, 5 squared is 25 over 240 minus 1 over 15. So now, put this in on your calculator, perform all this, you'll get 13 over 60 minus 23 over 240. And if you evaluate this, what you get is 5 over 16. Okay, so that's the exact probability that the amount of time Lloyd waits to be served is between 5 and 10 minutes, so 5 over 16. Part C, another quick one, we just got to find the median of t. So again, we're using this CDF. To find the median, well, all we've got to do is set this middle function here, this t squared over 240 minus c, equal to a half, because remember the median occurs when it's halfway through. So if we set this equal to a half, so instead of it being t, I'm just going to change it to m for the median, so it's going to be m squared over 240 minus 1 over 15 is equal to a half. Okay, on 0.5. So now, all I've got to do is keep simplifying this, so m squared over 240, if I add 1 over 15 to both sides, that'll give me 17 over 30, so 17 over 30. Now, times both sides by 240, I'll get m squared is equal to 136. So therefore, all we've got to do is square root this. Now remember, because what this question is looking at is time, we clearly can't have a negative solution. That wouldn't make sense. We'd have negative time. So my answer will just be the positive solution here. So that would be 11.5 11.66. Okay, so my medium is 11.66. So medium 11.66. Okay, so that's part C done, and we're actually on to the final part now. So we're flying through this question. We have to find the value of k such that the probability that t is less than k is equal to 2/3 of the probability that t is greater than k. We've got to give our answer to 3 significant figures. So, similar to how we've just done the previous ones using the probabilities, but for this one, because we've got to find the probability that it's less than and then probability that it's greater than this certain value here, this k that we don't know yet, we're going to have to use the integration limits. So, if we change our integration limits, well, what we're doing is we're integrating again, just like we did here. All we were doing was integrating to get this. So I'm going to do the same again. So it's going to be t over 120 dt. It's going to be equal to the integral of t over 120 dt. Now, obviously, I've got to get my limits right for this, or this just doesn't make sense at the minute. So, my limits now, well, if we're saying that it's less than k, well, if it's less than k, then my lower limit has to be 4, right? Because if you look at where it goes from 4 to 16. So I can't be lower than 4, so 4 has to be my lower limit, and it has to go at some point to k. Same again with these limits. Because this is t is greater than k, well, k must be my lower limit this time, and it must be somewhere between k and 16, okay? So all I've got to do now is perform this integration here, so I'm going to get the same thing, just plugging in different limits. So remember, this is just t squared over 240. So what I've got now is, so if I plug this in, this would be k squared over 240 minus 1 over 15. Okay, so that one's nice and easy. So that's k squared over 240 minus 1 over 15. Well, it's going to be equal to 2/3 of, plug 16 into here, so that'd be 16 squared over 240, which will simplify to 16 over 15, minus k squared, k being my lower limit, so minus k squared over 240. Now here, all we've got to do is just keep simplifying this. So if I change my pen colour, let's try blue, hopefully it looks okay. So if we go all the way up to the top here, simplifying this now, I can collect the k's on the left hand side, so this would be k squared over 144. So I've done 2 over 3 times this and then added it to the left hand side. I've got minus 1 over 15 if I add that to both sides, and don't forget to do this expansion here, so 2 over 3 times 16 over 15 plus 1 over 15, and what that'll give you is 7 over 9. So 7 over 9. So therefore, to get k squared, I've just got to multiply by 144. So k squared is equal to 7 over 9 times 144. So the k squared is equal to 112. And then finally, we've got to take the square root. And similarly to how we just had it in part C, I can't have a negative solution for this question, because in terms of the question we're looking at time, right? I can't be looking at the probability that it's less than a negative time. It just doesn't make sense. So k will be equal to 10.58, but because it wants it to 3 significant figures, that would be 10.6 to 3 significant figures. Okay, and there we have it. So that's question 2, fully complete.